In this lesson, we are going to use ESP32 module and ESP32 camera extension module from SunFounder to use this line detect module to detect black line on a white surface, or maybe even the opposite. Right now on the screen we see it says black because there is nothing, and if I go on the white, it detects the white, and we can see here the white, and if I bring it on the black, it detects it black, white, black. And we can use this for our robot car to detect the line, or for any other application that you want. And then I'm going to show you how to add a buzzer when it is on the white surface. There nothing happens. When it detects the black line, it buzzes like that. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do, or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud, or do the control, or read information or values via your mobile device or your desktop, or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi, either through the cloud or to your network. And also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. Line detector has a lot of application in robotics and robot cars and robotic arms and proximity sensors in industry as well. I'm going to use this line tracking module to detect the line. For example, we have a white surface and we have a line. This is a tape, and we are going to use this. This can be used with a robot car or robotic arm, whatever it is, that when it reaches this line, it can detect the line. So if this is attached to a robot car, it will detect this line. Initially it will start on the black, and it will detect the reflection that it is black. If the car goes, for example, away from the path, or if the line changes, it goes back towards the black, and it goes back this side when it detects the black, and it knows the previous state was white, black, so it will go back. So this way it can just go on the line and stay on the line if you program your car. So let me connect the power and let's see. As you can see, the first circle completed, and it can do it as many times as you want. So this has transmitter and receiver. We have an operational amplifier. So this will get the reflection. One is the transmitter. This will transmit infrared, and infrared will reflect back. The amount of intensity depends on the surface. The white surface will reflect more than the black surface, and as a result, we can distinguish this and adjust the sensitivity of this operational amplifier with this potentiometer, and we can get output from the S signal, either 0 or 1. And we're going to learn how to use this, either detect or do something. For example, in this case for the buzzer, right now it's on the white surface. I've programmed it so it doesn't buzz, but when I bring it on black, it buzzes, and it is telling me that there is a black line. When using ESP32 from SunFounder, it comes with a lithium battery, with a charger, everything. You just connect it to USB and the battery will be charged, so you can connect it and use it without a USB connection. Come to this page, docs.sunfounder.com, scroll down until you see ESP32, then click on ESP32 Starter Kit Main. On the left side, click on Arduino User, and then scroll down until you see 5.4, the text line, click, and here, this is our documentation for today's lesson. We're going to use the line tracking module to detect the presence of black background on the white area. So we are going to detect white and black, and it works with infrared. This is we need ESP32 module, ESP32 extension, camera extension module, jumper wire, and the line tracking module. If I click on this, here is the full explanation. This module has 3 pins. S is the signal, the output. V plus is connected to 3.3 volts to 5 volts, and then we have G or ground. This is the module in here, that is TCRT500, and the blue is the infrared LED, and the black is the photoresistor. So we will send signal using this piece. The infrared ray will go and it will hit the surface and it will come back. Depending on the surface, if we look, it's exactly like this module. It looks exactly like this. So we have a transmitter which emits the infrared, and when it hits the surface, if there is nothing, it will never reflect back. But if it hits the surface and comes back, the amount of intensity that returns depends on the surface. If the surface is black, we have very weak reflection. If a surface is more brighter towards white, we will get very high reflection, and as a result we will detect between black and white. And this module, on the module we have this operational amplifier of LM393, which compares the signal from the receiver, and it outputs 1 when the voltage is set, the value that you set, otherwise it will output 0. When the infrared emitter tube shines on the black surface, because the light is absorbed, the photoresistor receives less infrared light, and the LM393 will compare it and will output high level output when it is black. And when it is a shiny surface like a white surface, and we will get higher light reflection, and as a result the photoresistor will be decreased, and therefore we will have low output in the output, and LED will turn on. Surface, the LED will turn on, this LED here. We can use any of these pins that are mentioned here, and this is the schematic diagram. Signal, the G is connected to ground, V plus is connected to 3.3 volts or 5 volts, doesn't matter, and then S or signal is connected to IO14 or pin 14. Here is the wiring diagram, the actual wiring, which I'm going to explain in the wiring section. And this is the Arduino code, which I'm going to explain it in the code section. Now let me show you the wiring. This is our actual wiring, and this is our piece. We just need 3 wires, male to female, like this. Get it? And then let's connect it. I'm going to connect this green to the signal side. So we have ground, VCC, and signal, as you can see here. ground, I'm going to connect it. The last pin is ground. I'm going to connect ground to the ground. USB is this side, second pin from that side is ground, and also second pin on this side is ground. The middle pin is V+. We can connect it to 3.3 volts or 5 volts. And I'm going to connect it to 5 volts. And then the S signal is connected to pin 14. The last pin, which is green, the last wire. So pin 14, between pin 14 and ground, we have 2 empty holes. Wiring is now completed. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads. Then ESP32 Starter Kit Main on the right side. Double click to open it. Double click on C. Double click on Codes. I'm opening Arduino IDE. And then scroll down until you see 5.4, detect the line. Double click to open it. Select the file and click open to open it. So here we have defined pin 14 as line pin of type integer, and we set it to constant, so this cannot change. Line state is a value that is holding the value that we read from the line sensor. Inside the setup function, which is from here to here, we have just these 2 lines. This line says serial.begin, and that's the baud rate or communication rate that Arduino program communicates with the microcontroller, and via USB we get information back. Pin mode function, we pass the variable and set this pin, this line pin or pin 14 as input. So we are reading, and this will run only once. Inside the loop, which starts from here and ends here, this will continuously run, and we use digital read to read the line pin. We can also type here 14, but for better programming we use variable, so this will read the line value. If the surface is black, we get 1. If the surface is white or more reflective, we get 0, and the value will be stored in the variable called line state. And we use this conditional statement, and we check if line state is equal high. So if it is high, then we print this text on the screen. We say black, and we have 100 millisecond delay. Else mean it's not high, it's low. So if it is low, then it means we have a white surface, and we print this text on the screen to know it, and then we have a 100 millisecond delay, and the loop reaches here, the code, and it comes back, and it will continuously read the value and print something on the screen, either black or white. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, So 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Now on this white surface I have a tape, and this is our sensor connected to ESP32. And first of all, let's have a look at this. Now if I bring my finger, you see we get the reflection. It's because when there is a reflection, it will read. Now I have this surface, so I can demonstrate it. This is a black area and that's a white area. And let me put it so you can see the light. You see there is now reflection, and if I bring it on black, there is no reflection. Reflection on the black, on the white, reflection on the white, so we can get the LED on and off. Now the same way it will work in here. You perhaps see the black. Now let's open the serial monitor. Once you open the serial monitor, make sure that you see this value here, 115,200. This value must match. If I make it, for example, 9,600, you will see something like this, and it will not be readable. Make sure that it matches, because this is the baud rate. And that's the value that communicates with. Right now it is good, but here it says black because I've left it up. So it is detecting, but you see the potentiometer looks like that. So this is straight, and to increase the sensitivity we can rotate it with this potentiometer with a screwdriver. Pay attention to the light. I go left and nothing happens, and if I go right, now what does it mean? It means that I've increased sensitivity so much that even now, even though there is nothing, we are reading it. But it will be very sensitive, so I'm going slowly to the left until it's off. Now this is very sensitive, which means I increase the sensitivity, and here it reads white. Even on the black it says black until no, so it doesn't work because it's too sensitive. So to reduce the sensitivity or the distance, just check it, and depending on the surface, we read now black, white. So it's perfectly working. And here, if you want to know the amount of current from ESP32, this is a data sheet for ESP32. So when you set the current for 3.3 volts, when you set it to high, the maximum, the typical is 40 milliampere. So that's huge amount of current. This is when it is high. If you want to set it to low, then it will be maximum at 28 milliampere. Now I'm going to show you the amount of current that this buzzer needs. I've connected it to 3.3 volts. First, let me show you the voltage. This is negative and that's a positive. So let's see the voltage first. 3.28 volts. So that's 3.3 volts. I'm connecting the negative to the negative, and then this positive to the buzzer, and let's read the current. So it's around 15 milliampere. Now I'm adding buzzer. I've measured the voltage. It is safe to connect it directly to ESP32 because it needs only 16 milliampere. So the black is connected to the ground, and this positive, I'm using it and connecting it to pin 27. 27 is the line beside the 14. And here's the code. I've defined pin 27 as an output inside the setup. I've just added this line, and in here under the line that says black, I've added this digital write and set pin 27 to high, so this will turn on when it detects a black line. So you can change it if you want that on the black, it should be off. Just change this to low, but for our purpose it will be high. Else when it prints white, we set the pin 27 to be low, so the buzzer will be turned off. And now let's upload the code. And here is the demonstration. I'm holding it on a surface, the buzzer is connected, and when I go up and down, as you can see, it buzzes, and when I bring it on the black surface, it buzzes, and when it's on the white, it doesn't do anything. And here, I'm going to put it here so you can see it better. Black, white, stop. And if I point it to a ceiling, because there is no reflection, we get the buzzer.